Welcome to the Explainer. Today we're going to pull back the curtain on something that feels like pure magic: AI image generation. I mean, you've seen these incredible, mind-bending images all over the place. But have you ever really stopped to wonder how a computer can dream up something so complex and detailed from just a handful of words? Or even crazier, from what looks like a screen full of pure static? Well, it turns out that a ton of these big-name tools, Stable Diffusion, DALL-E, Midjourney, they're all built on the same surprisingly simple and elegant idea. It's called diffusion. Okay, so let's get right into it. The whole thing is kind of like a magic trick, right? And it's a trick with two main acts: destruction and then creation. So on one hand, you've got what's called the forward process. This part's easy. We just take a perfectly good image and, well, we destroy it. We completely scramble the information. Then you have the reverse process. This is the hard part, the learned part, where the AI figures out how to take all that chaos and bring the original image back to life. All right, let's start with the easy bit, taking a beautiful image and just turning it into a mess of noise. So, picture this. We take an image. Let's use this piece of clothing here. Then, over a bunch of steps, let's say 50 of them, we just keep adding a little bit of digital noise. Think of it like TV static. We add a little, then a little more, and a little more until the original picture is totally gone. It's just random noise. Now, you might think we're just throwing random static at it, but nope. There's a method to the madness. It follows a very specific recipe called a noise schedule. This schedule tells the computer exactly how much noise to add at each of those 50 steps. A popular one is the cosine schedule, which is kind of cool. It adds noise slowly at the start and the end, but goes really fast in the middle. This actually helps the AI learn the really fine details later on. Okay, so the image is toast. It's pure chaos. Now comes the really cool part, the actual magic, teaching the AI to look at that static and see the ghost of the image that used to be there.
But how on earth do you even begin to train a model to do something like that?
Well, you can think of it like a giant guessing game, just on an insane scale. We grab a random image, add a random amount of noise to it, and show it to the AI. We ask it one simple question: what did this used to look like? It makes a guess. We compare its guess to the actual clean image, show it where it went wrong, and then we do that again and again, millions and millions of times. And as you'd totally expect, right? If there's only a tiny bit of noise, the AI is pretty good at guessing the original with lots of detail. But if you give it something that's almost pure static, the best it can do is predict a very blurry, vague shape. All the detailed information is just gone. Okay, so this is where all that hard work, all that training pays off. This is the moment we've been building to, creating a totally new image, something that has never, ever existed before. This is the big what if. The AI is now a grandmaster at denoising. So what happens if we trick it? What if we give it a canvas of pure static, something that never had an original image, and we ask it that same old question: hey, what did this used to look like? What it does is amazing. It starts by predicting like a blurry ghost, an average of everything it's ever learned. Then, step by step, it starts to refine that guess. It takes its own blurry prediction and cleans it up, just a little. Then it takes that result and cleans it up again. It keeps doing this, pulling more and more detail out of the void, until a sharp, coherent, brand new image emerges from the chaos. But for this whole refinement process to actually work, the AI needs a secret weapon. It needs a very particular kind of digital brain that's built for exactly this kind of job. And that brain is called a UNet. It's a type of neural network that is absolutely fantastic at image-to-image tasks. The real genius here is something called skip connections. Think of it like this. As the AI is processing the image, these skip connections are like little express lanes that carry crucial, fine-grained details from the early stages directly to the later stages, making sure nothing important gets lost along the way. Okay, but wait a second. This is all great. But how does the UNet know how much noise to remove? How does it know if it's looking at an almost clean image or a total chaotic mess? Well, this is the really clever part. We cheat. We actually just tell it. At every single one of those 50 steps, we feed it a little signal called a time step. It's just a number that says, hey, you're on step 45, or hey, you're on step 3. This gives the model crucial context. It's like telling it,
Okay, be aggressive, there's a ton of noise to remove, or be gentle, we're almost done, just make a few small tweaks.
And that's, right there, is the core idea behind this whole thing. It's so elegant when you really think about it. To create something beautiful and new from nothing, the AI first has to get absolutely perfect at reversing destruction.
It's just an incredible process, and it really leaves you with a big question to chew on, right? If an AI can learn to make art by finding order in pure chaos, what does that tell us about how we create things? What does it say about our own creativity?